Electron configurations are important to understand once we start talking about how atoms are going to interact with each other to create molecules. So when we're talking about electron configurations, these are really, for our purposes, going to be pictures that show how the electrons are oriented around the nucleus. And this is important because while those electrons are located outside of the nucleus, and we've talked about how they're spinning around all of the time outside the nucleus, these electrons are going to be located in what we call energy shells or energy levels. So we want to understand what an energy shell or level actually is. So if we draw here a nucleus to start with, this is going to be my nucleus, and I'm not going to show that in a lot of detail because that's not the point here. We know that the electrons are going to be located outside of that. So electrons can be at different distances from the nucleus. So we could have some that are located relatively close to the nucleus, and this distance will be what we would call the first shell. We could also have electrons that are located a little further away. That would be the second shell. And then we could have the third shell, and we could do fourth shells, and so on. And as we increase the numbers here from first to second to third and on, we are increasing the distance from the nucleus. And as we increase the distance and move outward, we also have increasing amounts of energy. So what this means is that if we happen to have an electron that is located right here, that electron will have less energy than an electron that is located on the second shell. And both of those would have less energy than an electron that happens to be located even farther out than that. So when we talk about electron configurations and we start to draw electron configurations, we will be placing the electrons at specific distances from the nucleus, or in other words, we will be placing them in different energy shells. As we talk about electron configurations, let's look at an example using an oxygen atom. The very first step when we do draw configurations is that we need to know how many electrons are we dealing with, because this will tell us where we need to put these electrons in the energy levels. In this example, notice that there is no charge being shown right here as a superscript, so that tells us that we are dealing with a neutral oxygen atom. Since this is neutral, if we have 8 protons, then we must also have 8 electrons. That's the only combination that would give us that neutral charge. So we are going to draw the electron configuration using 8 total electrons. So I'm going to start off by drawing my oxygen nucleus. And again, we don't need to put much detail there, just a spot or a dot would be fine for that nucleus. And then we're going to start off by filling the first shell first. So the first shell, the rule is that it holds a maximum of 2 electrons. It cannot hold more than that. So I'm going to draw a ring around here to represent my first shell, and I'm going to place 2 electrons as little dots there on that shell. Now, when I place those 2 electrons on that shell, they're going to be placed right next to each other, and this is what I would call a pair of electrons. This will become important later on when we talk about the bonding behavior of different atoms. Once I've filled up the first shell, then I can move on to the next shell out, which in our case is going to be the second shell. And the second shell, the rule is that it holds a maximum of 8 electrons. And so as I draw this second shell around here, I do have another 6 electrons that I need to put on here, just due to the fact that oxygen has a total of 8. And so I'm going to be able to fit the rest of them in this second shell. Now, as I look at the second shell, I do want to think of this as having 4 different locations around it, so a top, bottom, left, and right. And the rule is that we want to place 1 electron into each one of those 4 spaces before we start to put 2 electrons into the spaces. I always start at the top, but you could start at any one of the 4 positions, and we're going to place 1 electron there, and then we'll move our way around the circle. So now I've placed on 4, and then my 5th one I can put right next to this one, and the 6th one right next to this one over here. And at that point, I do have my 8 electrons all on the diagram. Now when we look at these, the purple electrons, as I've drawn them, those would be higher energy electrons than the green ones, and that's due to the fact that they are located further out from the nucleus. And then the other important thing that we want to think about is that we do have some electrons that are paired up, and we have some electrons that are unpaired, or they are singles on the outside shell. We do have a specific name for the outside shell, so whatever the outermost shell is, that is going to be called our valence shell. And the electrons in that shell will correspondingly be called valence electrons. The valence shell is the most important shell for bonding purposes because that is the outer boundary of the atom, and that's what will be available to interact with neighboring atoms.